Hello and welcome to a screencast on characteristics of stars diagram. This is very exciting. You're going to want to have your Earth Science reference table out and you're going to open it to page 15. Okay, so here we're looking at a graph on the characteristics of stars. When we look at stars, we look at the temperature of the star in Kelvin, and we're looking at the luminosity of the star. Luminosity meaning how bright it is. We're comparing this brightness to the sun, which it says right here. Okay. Down here, we have the color of the star. And the colors of the stars correspond with the temperatures. Now this graph is a little bit strange in that it's reversed. The numbers are reversed. If you look at the bottom here, they start with 30,000 Kelvin and it goes to 2,000 Kelvin. On the luminosity part, it's not reversed. It goes from the least to the greatest. On this side of the y-axis, we have small stars and massive stars. So this corresponds to luminosity. Small stars are not as luminous as massive stars, which are very luminous. When we're looking at the color of the star and the temperature of the star, if we're about 30,000 Kelvin, then you have a color of blue. Blue-white stars would correspond with these temperatures here, white, yellow, orange, and the coolest stars are red. When you're looking at your numbers, it goes from 30,000, 20,000, 10,000, which means the values in between 10,000 and 20,000, there would be a range of values in between here. Now this is a graph, which means that they took a bunch of stars and they plotted it on a graph. We are not looking at the nighttime sky here. So if we were looking at the sun is plotted right here. There's the sun. It's plotted on the graph here. It has a luminosity of 1 and a temperature. If you follow it straight down, you should do this on your graph, if you follow it straight down, it doesn't exactly land on 6,000 Kelvin. It's actually in between 4,000 and 6,000. So we're looking here, actually 5,000 and 6,000. If we're looking here, we know that it's about, maybe we'll say 5,700 Kelvin. And in terms of size, it really is just a small, medium star. It's not massive, it's not extremely small, it's really just a small, medium star. This is how we read this graph. If you notice on the graph, it's broken up into sections almost. Right here, we have a bunch of stars plotted just like this. These are our main sequence stars, or our early stage stars. So main sequence tells us really the age that it is. So we have our early stage stars, which is really the midlife. Up here we have our intermediate aged stars, which are giants. If you have a really large intermediate stage star, it would be classified as a supergiant. And then our late stage or really old stars are white dwarfs. That classification is here. So this graph not only does luminosity, temperature, it does the color, the size of the star, and it tells you what part of its life cycle it's in. So again, we're going to look at our sun. Our sun has a luminosity of 1, a temperature of about 5,700, and it's in the early stage or the main sequence stage of its life. Looking at this, you can actually see that most of the stars, 90% of stars, are actually graphed in this main sequence. So this is where most of the stars would be graphed. However, as our sun gets older, it won't be graphed here. If you came back in, I don't know, a couple million years, it would be graphed someplace else. Let's take a look at the star Sirius. Here's Sirius over here. Very Sirius. Sirius has a luminosity, if you follow it over, it's greater than 10, but less than 100. And the temperature of it is not at 10,000. I would say it's probably 9,900. Okay, so this is how you would read this graph, and it's also in the main sequence stage of its life. Let's take a look at Aldebaran over here. Now, Aldebaran is a much cooler star than the Sun or Sirius. So you'd follow it down and read the temperature this way, okay, and your luminosity, you'd read it this way. Even though Aldebaran is cooler, it happens to be more massive, which means that it's more luminous. The more massive the star, the more luminous the star is. And you can see, unlike our sun is here in the color yellow, if you follow it straight down with this temperature. Aldebaran is more orange. Betelgeuse, extremely more massive. It's also in the intermediate stage of its life, but it's a supergiant because it's more massive. Let's see, what else do I want to tell you about this lovely organization of information. If we take a look at our main sequence stars, you can see that there's a relationship. The more massive the main sequence star, the hotter the star is, and it's more luminous. All right, I think that's all I have to tell you about how to read this graph. Answer the questions on the Google form, and we'll do a lab on it on Monday.